Here, we're going to go over some common issues from the Chapter 8 homework. This first one is from Chapter 8, Part 1, and as you can see, it's number 6. Remember, if you want practice, you can always look at the number and go look at the textbook in Section 8.1 and look at question 25. I'll give you a minute to read through the question. The first thing they ask us to do is to state a conclusion about the null hypothesis. So if we look, the original claim was that more than 55% of adults would erase all of their personal information online. So we can use that to figure out our null hypothesis and our alternate hypothesis. Remember, our null hypothesis always has to use our equal sign. We're talking about a proportion, so I'm going to use P equals. And the claim that we're making is that it's greater than 55%. So we're going to use that 55% in our null hypothesis in decimal form and say that P equals 0.55. Our alternate hypothesis, this H sub 1, is where we get to make our claim. Is it going to be greater than, less than, or not equal to? So because we're saying more than, that's where we're going to say our P is greater than 0.55. Now we use our p-value to make a decision. They told us that our alpha is that 0.05. And they told us that our p-value is 0.3376. Remember that p-value denotes how likely this event is to occur based on our sample. So if we have a p-value that is less than or equal to our alpha, that is when we reject our null hypothesis. But if we have a p-value that's greater than our alpha level, that's when we fail to reject our null hypothesis. So if we look at what's going on, our p-value of 0.3376, that is very definitely higher than our alpha level. So because it's higher than our alpha level, we are going to fail to reject our null hypothesis. So if I look at my multiple choice options, I want the fail to reject. And it's because the p-value is greater than alpha. So I'm going to choose option D. Then they tell me without using technical terms, I want to state a final conclusion. Pretty much whenever we're stating a final conclusion, we're going to look for the words sufficient evidence. Either there is sufficient evidence about a claim or there is not. So because we failed to reject, there's not sufficient evidence to support the claim that the percentage of adults that would erase all of their personal information online if they could is more than 55%. So that's our option that we're going to choose. The rest of the questions that the class seemed to struggle with were from our Chapter 8 homework, Part 2. So we're going to look at number 9. Take a minute to read through the question. So they're not actually asking us to do any math here. They're asking us about the requirements. So the first set of requirements they're asking us is what requirements must be satisfied to actually test the claim. And there's 2 requirements that have to be satisfied. The first one is this option D. Either the population is normally distributed or n is greater than 30 or both. We saw that with our central limit theorem as well. The other requirement that has to be set is it has to be from a simple random sample. If we look at our answer for the bottom here, we don't have our n greater than or equal to 30, so we can't use our sample size. And then we also see that we need to figure out, is it a simple random sample? And they don't really tell us that information either. So because of that, I'd probably choose option F. They don't give us enough information to determine if it's a simple random sample. They just told us that there were 12 different video games, and we know the sample size is not greater than 30. We don't really know if it appears to be from a normally distributed population. You could definitely check that by plugging these into L1 in your calculator and then using StatPlot to look at a histogram to figure out what's going on. Let's look at number 10. Here, they're telling us that we're going to use a t-test, and then they're asking us what does DF denote and what is its value. So same thing, this is a definition question. DF is the numbers of degrees of freedom. And we know from watching those videos that the degrees of freedom is our sample size minus 1. So in this case, if we look at it, they tell us in words that 28 different video games were observed. So that means our N is 28. So our degrees of freedom is 28 minus 1, or in this case, 27. Last but not least, we're going to look at this number 11. Here, we actually do have to do some math. And they tell us to use technology to find the p-value for the hypothesis test described below. So they tell us that the claim is that for our smartphone carriers' data speeds at the airport, the mean is 16 megabits per second. So if we're thinking about our null hypothesis and our alternate hypothesis, the thing that we're actually claiming is that our mean is 16 megabits per second. So that means our alternate is that it's not. So if it's not that amount, that's when we use our not equal to. So if we try to think about what's going on here, they tell us that we have a test statistic of t equals 2.036. So remember that t distribution looks like our normal distribution, just it's generally a little steeper. So what they're telling us is that we have our test statistic right here of t equals 2.036. But because we have a not equal to, that means that this is a two-tailed test. So we need to find the area over here beyond that 2.036, and then we also need to find the area over here beyond t equals negative 2.036. So if we need to find the area from a t distribution, we're going to use this on our calculator. We're going to go to our second distribution, and then option 6, our t CDF. So we're essentially going to do the same thing we did back in chapter 6 with our normal CDF, but with our t distribution. When we do that, they ask us for the lower, the upper, and the degrees of freedom. So I'm going to focus in on this right-hand side because it's what they give me in the problem. If I do that, my lower is going to actually be that test statistic, 2.036. If we think about our upper, technically it's positive infinity. It's going all the way over here as far as it can go, but I can't type that in, so I'm just going to type in a whole bunch of 9s. And then they also ask for my degrees of freedom. Remember, that's our n minus 1. So in this case, that's our 24 minus 1, which is where I got that 23 from. When I type all of this in my calculator, I get 0.0267132.663. Now remember, that's this area, the area to the right. But if I'm thinking about the p-value because it's a two-tailed test, I need the area to the right and the area to the left. So just like our normal distribution, our t distribution is symmetric. So that means this area over here is the same exact amount. So to find my p-value, I'm going to do that area, that 0.0267132.663, times 2. And then they tell me round to 3 decimal places as needed. So when I do that in the calculator, I get 0.0534265325. And then I go 1, 2, 3 decimal places. That 4 tells me to leave that 3 alone. So that means that my p-value is 0.053. That's it for chapter